What if an AI could not just answer your question, but actually go do the job for you? Book the meeting, write the code, run the analysis, send the report, and come back when it is finished. That is not science fiction anymore. That is the future of AI agents, and it is closer than most people realize. To understand where this is going, you need to understand what makes an AI agent different from the chatbots most people have already used. A chatbot responds. You type, it replies, and then it waits. An agent acts. It takes a goal, breaks it into steps, uses tools to complete those steps, checks its own work, and keeps going until the goal is done. The tools an agent can use are what give it real power. An agent can browse the internet, read and write files, run code, call APIs, fill out forms, and interact with software just the way a human would. Give it access to the right tools and a clear enough goal, and it can handle entire workflows from start to finish. This is why the jump from large language models to AI agents is such a significant one. A language model is a prediction engine. An agent is a system that uses that prediction engine as its brain, wrapped in a loop that keeps acting, observing, and adjusting until the task is complete. That loop is everything. Now, here is where it gets even more interesting. Researchers and engineers are not just building single agents. They are building networks of agents, where each agent is specialized for a specific type of task. One agent plans, another writes code, another tests that code, another handles communication. They hand off work to each other like a coordinated team. These multi-agent systems can solve problems that a single model simply cannot handle. When a task is too complex, too long, or requires too many different types of reasoning at once, breaking it across a team of specialized agents produces much better results. Companies are already using this architecture inside real products today. One of the most important capabilities on the horizon is what researchers call long horizon planning. Today, most agents can handle tasks that take a few minutes and a handful of steps. The next generation of agents will pursue goals across dozens or even hundreds of steps, over hours or days, adapting their plan as conditions change. Think of it like the difference between a sprint and a full project. Long horizon planning requires something current agents are still developing: reliable memory. To stay on track across a long task, an agent needs to remember what it has already done, what it discovered along the way, and what it still needs to do. Several teams are working on external memory systems and new model architectures to make this persistent memory possible. The hardware story matters here, too. Faster inference chips, larger context windows, and cheaper compute are all quietly removing the ceiling on what agents can do. When running an agent for an hour costs the same as running it for a minute used to, the economic case for autonomous AI workflows becomes very hard to argue against. Let us talk about where agents are already being deployed, because this is not all theoretical. In software development, agents are writing code, running tests, catching bugs, and opening pull requests. In finance, agents are monitoring markets, flagging anomalies, and generating reports. In customer operations, agents are handling complex support cases end-to-end without a human touching them. Healthcare and scientific research are two areas where the potential is enormous. AI agents are already being used to scan medical literature, propose hypotheses, and even design experiments. The speed at which an agent can process research is orders of magnitude faster than a human team, which means discoveries that might have taken years could start taking months. For businesses of every size, the shift to agentic AI is starting to look less like an upgrade and more like a restructuring. When a single agent system can do the work of an entire workflow, companies do not just save time. They start asking which roles, which processes, and which departments need to look completely different. None of this comes without serious risks. The more autonomy you give an AI agent, the more important it becomes that the agent does the right thing. Alignment. The problem of making sure an AI pursues the goal you actually want in the way you actually want it pursued gets significantly harder when the agent is taking real actions in the real world. Reliability is the other major challenge. Current agents make mistakes. They misinterpret instructions, get stuck in loops, use the wrong tool, or confidently take the wrong action. In a low-stakes environment, that is annoying. In a high-stakes environment like managing a financial system or a medical workflow, the cost of errors is very different. This is why the field of AI safety is growing at the same speed as the field of AI capabilities. Researchers are working on interpretability tools that let humans see inside an agent's reasoning, on sandboxing systems that limit what an agent can touch, and on verification methods that confirm an agent's plan before it takes action. Progress is real, but there is still a lot of ground to cover. Regulation is entering the picture too. Governments in the United States, the European Union, and several Asian countries are all working on frameworks for how autonomous AI systems should be governed. The rules are not finalized, but the direction is clear. The more consequential an agent's actions, the more accountability humans will be required to maintain. For people thinking about careers and skills, the most honest advice is this. The jobs most at risk from AI agents are not the ones that require the most knowledge. They are the ones that are the most repetitive and the most process-driven. The roles that stay valuable are the ones that require judgment, creativity, and the ability to set good goals for agents in the first place. Learning to work with agents, not just alongside them, is becoming a real skill. Knowing how to write a good prompt is table stakes. The next level is knowing how to design a task that an agent can execute reliably, how to verify the output, and how to build a workflow where human judgment and agent speed are both applied at the right moment. The trajectory here is not gradual. The jump from text generation to basic agents took about 2 years. The jump from basic agents to reliable multi-agent systems capable of long-horizon work is happening right now. By the time most people have adjusted to what AI agents can do today, the next generation will already be in deployment. The future of AI agents is not a single moment when everything changes overnight. It is a series of capability jumps, each one expanding what is possible, each one asking businesses, workers, and policymakers to adapt faster than they expected. The people and organizations who understand the technology deeply will have a real advantage over those who are just watching from the outside. If this video gave you a clearer picture of where AI agents are heading and why it matters, hit the like button. It helps this channel reach more people who want to understand AI without the noise. Subscribe so you do not miss the next video, where we go deep on how multi-agent systems are being built right now and what the architecture actually looks like under the hood.